Linear approximations and differentials. So suppose we have a function and we take the derivative of a function at a single point. Well, we know that the tangent line will approximate the behavior of the function in a small region around that point. In other words, when we zoom in on a function at a particular point, at least at a certain amount of zooming in, it looks like it's pretty close to a straight line. And so what this suggests is that we could take dy dt and approximate that as a delta y over delta x, a change in y over change in x. And thus, especially if the change in x were relatively small, that might allow us to approximate the change in y. So here's a particularly useful example: how to find the square root of something like 9.1. Well, that would be a particularly hard one to figure out without a calculator. But suppose we consider the function f of x equals square root of x. And of course we know that if we plug in 9, we get an output of 3. We know that it goes through that point. Well, let's take a derivative of this function. F prime of x, of course, equals, well, of course, square root of x, we can think of that as x to the 1/2. So the derivative of that is 1/2 x to the negative 1/2. I'll simplify that as 1 over 2 square root of x. And if we think of this now as a dy, a change in y over a change in x. So in other words, we know that this point goes through, function goes through the point 9, 3, and we want to know what happens if we just move 0.1 beyond that. We're moving from 9 to 9.1. And so right there, when we plug in, we get a slope, f prime of 3. We get a, f prime of 9, we get a slope of 1/6. So we know that 1/6 would be approximately equal to dy over dx, and for dx I'm going to put in 1/10. Solving, what we get is that delta y equals 0.1 over 6, or simplifying that to 1/60th. And so that means that our approximation for the square root of 9.1 is the original value of x, the original value of y, which is 3, plus the delta y, which is 160. So 3 and 1/60th. And 3 and 1/60th is 3.016666 repeating. Turns out if we actually figure out the exact value of this on a calculator, it's 3.0166206. So it means that by this very simple procedure, we've been able to create a decimal that agrees to 4 decimal places, which is actually rather extraordinary. And so this is the advantage of using differentials and linear approximations.